So we'll talk about multi-threading. I'm going to create a new package for multi-threading. I'm going to create a first class A. Okay. And then I'm going to write one simple we know about this, right? I'm just trying to write a for loop int I equal to 0, I less than 10, I plus plus, and inside the for loop I am writing a s out. I am just printing I. So this is a very simple program that we learned earlier, right? So what do we have in this program with respect to multi-threading? So we know how this works and what is the output that we are going to get, but there is something multi-threading concept is involved here. Okay, what is that multi-threading? So whenever we write any Java program, there will be three threads will be running. Three threads will be running. What is that? One is thread scheduler or scheduler. Thread scheduler. Second one is garbage collector, and third one is main thread. So what this thread scheduler does is, we had never seen this so far, but this is part of the JDK. This is part of the Java itself. Okay, even the garbage collector also same thing. We learn about this even in detail, even much later. And then we have the main thread. Main thread is nothing but a thread which starts the main method. Is called as the main thread. Basically, whenever we are running any Java program, these three different threads will be running in the background. These three different, I can say, the processes or the threads, I can say, right? So what it does is, one is scheduling. The name suggests scheduler. It schedules the threads, which thread has to pick up which task and when to pick up and what to execute. So this thread scheduler will take care of it. And then we have something called garbage collector. In short, garbage collector is nothing but to clean up the unreferenced objects or unused objects. In a simple words, unused objects. If there are any unused objects, the garbage collector will be running in the background, and then it will be seeing if it finds any unused or unreferenced object, it will just delete it. And then we'll have the main method. So main method is always responsible to run the main method. Okay, so for now let's keep these two things aside, the thread scheduler and garbage collector, for now, right? We focus more on the main thread. As I said, main thread is responsible for main method. Whenever I run any program, if you noticed, it always starts with the main method. Why it always starts with the main method? Because I used to write many other methods like test 1, test 2, test 3, method 1, method 2, a lot of methods like that, right? But why it always starts with the main method? Because there is a predefined logic inside Java, that is the main thread. Main thread is available. That is what is defined within Java. So this main thread's job is to always trigger the main method for the first whenever we execute a program. Okay. Now this is a simple program. I am just trying to run this. So the output is 0 1 2 3 4 5 6 7 8 9. It has all of it has come in a sequential, right? So first it goes inside, then it becomes 1, and then it comes back, then the next value, then the next value, likewise it is going to print. So since Java is already providing main thread, we also can create our own threads. We also can create our own threads. What are the various ways to create the threads? There are two ways. One is extending the head class, and second one is implementing runnable interface. These are the two ways. So extending the thread class is nothing but simple inheritance that we learned even today's class also. You can just write class A extends thread, that's it. And implementing the runnable interface, if you remember in the previous batch, we learned about the interfaces, how to work with the interfaces. So that is the second way. First, we'll focus on the first one, extending the thread class. I'm going to create a new class now, class B. So how can I create a threading? How do I implement the threading? Extending the thread class. So I write extends thread. Thread is already available within Java. If you just type th, you can see thread here. While choosing thread, there are multiple threads. Here there is java.lang, and there is one sun.jvm.hotspot.runtime, and another deprecated one. Whenever you see the striked out line on anything, that means that is the deprecated one. It was using earlier, but now we are not using it. That is the meaning of this. Okay, so I am choosing the first one, thread. Okay, if I do this, I have something that I need to override a method. Let's say, for example, here for int, I'm going to write the same logic. I equal to 0, less than 10. I just put 5, I plus plus, sort of. This is a simple program B which is extending the thread. If you are extending the class thread, it is always mandatory to override the run method. So this method, it is mandatory. Inside the logic, you can put anything, but you need to put this method for sure. We'll understand why you are putting it very soon. Now I am going to create another class. Let's say I don't even need to go to another class. I put it here itself. Yes, yum. It. How do I create the object for class B? B1 equal to new B, right? So if I want to run this, if I want to call this method, how do I call? This is a static method or non-static method? Non-static, because we don't have the static keyword, right? So how do I call? B1 dot run, but we are learning about the threading, so there is a different way. I do B1 dot start. If I do the B1 dot start, that means a new thread is going to be started for executing this method. We already have the main thread which can start the main method automatically. But now I'm going to start a thread. I'm going to create a thread which is responsible to call this method automatically. Okay. Now again I'm putting the same logic here. Here I'll start it from 5 to 10, so that we'll have the differentiation. By just, let's say for example, if you call the start method, it internally calls the run method. So that is the concept of thread. You don't have to, you should not directly call the run method. That is a mandatory step. We should not directly call the run method. If you call the run method directly, that gives a different meaning. But here our purpose is to start the thread. Okay, how do we start the thread? We'll create an object, right? On that object, we call the start method, which is available inside thread class. Start method is not available here, but why it is not giving the error? Because we are extending the class thread. If you go inside the thread class, you can see the all the readily available methods. Down, control F12. These many methods are there. Whatever is in this class, thread class, these many methods are there. You see the start method here. Okay, so this is the method is being called. Inside the start method, it will be calling the run method. Okay, now we already have one main thread that is responsible to call the main method, and we have another thread that is responsible to call the run method. Now by looking at it, what will be the output? As I said, start method will anyways call the run method. Okay, this is nothing but b1 dot start, b1 dot run. Okay, so when b1 dot run executes, what will be printed? 0 to 5. After once this is completed, then only it will come to the next number, next line, right? 16. Once it is completed, then it comes here and then it prints 5 to 10, right? But let's see the output, whether we get the same output or the different output. See, 5 5 is part of which one? The first for loop or the upper for loop? I less than 5. No, not first for loop, second for loop, right? Because it is less than 5, not equal to 5, right? So here it will come. 6 is part of which one? Second one. And 0 is part of which one? First one. And then 1, 2, 3, 4. So all of these are first one. Next 7, 8, 9 are part of second for loop, right? So it's all mixed up, right? You see any logic here? You don't see any logic here, right? Why it is printing this way? If I, please remember the output now, 5, 6, 0, 1, 2, 3, 4. If I run this program again, the output will change again. This time you will get the different output in the different order. See, now this had come, both of them had come sequentially, right? First this is completed, then this is completed. Now if I run it again, I am not making any changes in the code. I am just rerunning multiple times. You see, now this is a third different output, right? If I run it again, this is again different one. If I run it again, this is again the different one. So what is happening here? Why do we use multi-threading is, so that means this is also executing at the same time, this is also executing at the same time. That is the reason you are getting the output as mixed. So that is the main advantage of multi-threading. It's just like, let's say we are 10 people to do some work. Instead of going one by one, right? One after one, all the 10 people are going at a single shot and then doing the work. So everybody will be doing their own work and then finishing it. So that's the exact concept of the multi-threading. Clear any confusion here? If we don't do this multi-threading, each and everything will be sequential. The main words that you need to remember is sequential. But if you implement the threading, it is going to be a simultaneous. Likewise, now we have created one thread. Already there is another thread. That means two threads are running. If I create one more thread, b2 equal to mu b, b2 dot start. So this is going to be the another thread. Now again, that means three threads are simultaneously executing this program. So this main thread is printing this one simultaneously, and B1 is executing this, and B2 also will be executing the same thing. So we don't know, when 10 people are working on one thing, we don't know, right, which person will be finishing first. It all depends on their own energy and then efficiency, right? So what basically it does in the behind the screens is, so everything runs on the memory, right? Everything runs on the memory. Even for creating the object, it occupies some memory. Even for creating a variable, it occupies some memory. For creating a class, it occupies some memory, right? So what it does is, the common resource for all the things here is the memory. So the whole memory will be divided into three, divided for three different threads here. The whole memory. Let's say there is a 1 GB of memory. All the memory will be divided for three different threads. When we say 1 GB for three different threads, how much it might come for each thread? 1 GB by three, right? For each one. No, but that should be the one, but actually it will not work that way. I had talked about thread scheduler, right? So it is the job of thread scheduler to decide which thread to take how much memory. Which thread to take how much memory. Nobody has any control on it. It's the job of the thread scheduler completely. If you run it now, it may give 500 MB for B1 thread and 250 for these two. But if you run the same program second time, maybe B1 may get complete 900 MB and only 50 for these two. So in multi-threading, there is the output you cannot expect. The very basic thing is you cannot expect the output, but you need to have the clear understanding of how the multi-threading happens. Right? So basically, all the resources. When I say all the resources that means the memory or the CPU memory, right? So that's what the laptop or the computer will have, right? All of that will be depending on this thread scheduler, and this will decide which thread to execute when, which thread to start. So that is the job of this one, thread scheduler. Clear? Any doubts so far? Okay. Now I am going to write another simple program. In fact, I am just copy paste the same thing. Class. Here instead of start, what I will do is run, because that's what we have it right already. So now what will be the output now? If you are calling the run method like this, that means we learnt earlier, right? It will be the same flow. First 0 to 5, again 0 to 5, then 5 to 10. If you want to, you run this program any number of times, you will get the same output. Because here we are not starting the threads. See, 0 to 5 and then 0 to 5, 0 to 4, and then, right? The first loop two times, and then you run this program any number of times, you will get the same output. Because here we are not starting the threads, we are just calling the run method in a normal, as a normal run method. If you are calling the run method like this, then this run method will be a normal run method, just like a test or test 1 or test 2, whatever we learned. If you want to start the threads, you need to call the start method. The start method will internally call the run method. So that's when multiple threads will be created and then triggered. Clear? Now, especially for your projects, more focus will be on this threads. Why? Because their products itself are depending on the threading. So their products, I think I remember, yeah, they'll use a lot of things, right? I think white crash or something, right? So now we had just seen just two threads, but in real time projects, actually there will be hundreds of threads will be running, and memory also will be like in TBs, not even MBs or GBs. We'll have a servers which will be running on TBs or hundreds of TBs, very huge servers will be there. And when applications are running, if any application is giving not properly, not giving enough speed, right? So what they will do is they will extract one thread dump. In the interview they had asked this, what is thread dump? So what they will do is they will run some command, so that will give the details of all the threads, how many threads are running in this application, and which thread is taking how much time, how much memory, and which thread is doing which job. So all that information will be available in that thread dump. So your company is focusing on those data, so that, let's say for example, in my company, if I am facing any issues like this, if my project is working very slow, it is not giving the response faster, what I will do is I'll generate one thread dump and I'll use this y crash and then I'll upload it. So your y crash will do all the things and then gives the result to me in a very proper readable format. Otherwise that thread dump will be in a non-readable format, you will not understand anything. So your company's job is to read that non-readable file and then present it to us in a readable format, so that we can understand which thread, which function, which method is taking how much time, how much memory, all of that. So that's the reason, especially for your job, multi-threading is very, very significant. Usually multi-threading is bit complex topic, but since you started with this concept in the starting, so this is the most complex topic I can say in Java. But if you learn this, rest of all the other topics will be very easier. Even if you learn 50% of it, yes, it is definitely going to help in long term. Clear so far? I'll write another book class. I'll try to copy paste the same thing, but I'll change it slightly. Even dot. So what I'm doing it here, object is same. I am trying to start the thread twice, two times. Let's run the program and then see how it behaves. It gives the error because illegal thread state exception. So what happens here is we cannot start one thread twice. Same person cannot start the same work twice, right? First, in a very simple general terms, same person cannot start the same work twice, right? Exactly the same concept. So if the object is same, then you cannot call the start method second time. For every new thread, you need to create a new object that we had already learnt in the previous program. Okay, so this is very very important question, especially in the interviews. We cannot start a thread more than once, only once, maximum only once we can start. But let's say if I put b1 dot run, what will happen now? Yes, it will start and then execute properly. See, you had got the output. Irrespective of what is the order, you had got the output without any error, because this is the only place we are starting the thread. Second time, we are calling the run method in a normal calling a method. So this doesn't comes under multi-threading. This doesn't comes under thread. This is a normal call. Clear? So whenever if you want to create the number of threads, you need to create that many number of objects. So that means each thread or every thread belongs to object, not the class. Every thread belongs to a object, right? Not a class. So this is about creating the thread by extending thread class. Now let's see the second way. Class E. So what should I do here? Implements runnable interface. So as soon as I had written the implement runnable, it is giving the error because it is expecting to implement some methods. Just click on this. See, run method, it is forcing to implement. Right? So I'll put the same for loop here. I'll put only to 5. I'll write PSVM. It's 8 to 10. T1 is equal to new thread. New thread. Sorry, before this I need to create the object for E1 equal to new. So I need to pass this object. So T1 dot start. You see the difference now? Earlier we were just extending the thread class and then calling the start method. Now we are implementing the runnable interface. Then we are first creating the object and then I'm creating an object for thread, which is an internal class, thread class, right? And then while creating the thread T1 object, I am passing this object E1 here and then I am calling the start method on T1. Clear? So this is the way we can create by using the runnable interface. If you run it again you will see the different output. It all same all the time or yeah, sure, different. Both are used for the same purpose, but there are two ways. And now one important question here is we have two ways to implement the multi-threading. Which way we should use? What is the best way to implement the multi-threading? Is always the Second one, by implementing the runnable interface. Why? Because Java does not support multiple inheritance directly, but by using interfaces, we can achieve the multiple inheritance, right? So obviously, runnable is a interface. So for that purpose, we need to use runnable interface. Okay, now we are creating the thread, right? So thread is nothing but a another parallel process, I can say, right? Probably you can Google for the textbook definitions of what is thread. So thread is just another process. So this will have some properties. When I say when I was comparing with a thread with a person, obviously a person will have a name and his ID, mobile number, all such properties, right? Similarly, each and every thread also will have certain properties. Okay, so let's see what are those properties. I'll comment it out on this one because the main intention is to read the properties, not to run threads. Sort of e1 dot get id. So every thread will have its own id. Similarly, e1 dot get name. Sort of e1 dot get state. Sort of e1 dot get priority. Now these are the simple basic properties that we can understand right away. Otherwise, there are few more properties like e1 dot context class loader, stack trace, get group, uncaught exception handler, and also these are we can look at these things later. You will not understand now. So we just look at these things. Get ID is nothing but just gives the ID of the thread, and then name gives the name of the thread. State. So each and every thread will have certain states, right? Like new state, running state, terminated state. Once the execution is completed, it will be killed, right? That means that is a terminated state. Similarly, priority. Now, let's say whenever there are multiple threads, we did not have any control on it, right? Which thread to take the priority. So, thread scheduler was doing all that job. Which thread to take the priority and then which thread to start first, like that. Similarly, we also can define that priority. We'll learn that later, but each and every thread will have some priority here. If I run this now, you will see all this information. Thread ID is 11, name is thread 0, state is terminated because here when it comes here, thread is ended. That's the reason it is terminated now, and the priority is 5. The thread priority always starts from 0 to 10. Okay, 0 is highest priority and 10 is lowest priority. 5 is middle priority. Okay, is it enough or it is too much?
But we are not giving the value of I. Then how can we take priority is correct? Fine.
That's what the thread scheduler is there, right? I was telling the thread scheduler. Thread scheduler will be giving the ID, giving an ID and a name and its priority. So it's a job of thread scheduler to set it internally. It's a job of thread scheduler internally. So thread scheduler will be internally running. So that will take care of it. If I run this again, values may or may not change. I think it's same. But if I want, I can set the values. Set parity. Let's say, for example, if I put 1, when multiple threads are running, it has not changed because thread scheduler doesn't allow. We can set it, but it is not guaranteed that the values will work. The values that we give always works. After starting, we cannot change its priority. I think yes. Before starting the thread only, we can start. We can set the priority, right? Let's say, for example, let's say there are 10 people in our team. They are working. Once they start the working, we cannot set the priority, right? Because they already started. So before starting the work, we can set all these values. Even the ID name also we can set. But if we don't set it, thread scheduler will set it default values in its own way. But if you are doing any such change of information, we need to do it before the start method, not after start method. So is it okay for today or
అది కేజీ 1% అవుతుంది.
okay? I'll stop it here.